All right, so you should have already done this opening exercise where you were asked to dilate AB by the rule DC3, which is going to stretch AB out to A prime B prime down here, which is going to be 3 times longer. Now it said here use the ratio method. I didn't feel like using a ruler, so I used a compass. You can always use a compass if your ratio method is a whole number for your scale factor. If it's not, you are going to have to use a ruler. So basically what happened here is I got AB here, I got A prime, B prime there. If we were to find all the measurements, you would see that CA, this distance right here, when compared with CA prime, this distance right here, they have a ratio of 1 to 3. CA prime is 3 times bigger than CA, and you'd also find out that AB versus A prime, B prime has a ratio of 1 to 3. The other thing that you're going to see is that you're going to see if you measured all these angles, CBA, CB prime, A prime, is that these angles end up having the same measure. So what that also means is that AB is parallel to A prime, B prime, because if the corresponding angles are equal, then the lines are parallel. Now, what we ended up creating here is we ended up creating a triangle, CAB and CA prime, B prime. We actually have 2 triangles. We have this triangle right here, and we have the whole triangle CA prime, B prime, and that's what today is all about. So if I look at this picture, it's a lot like the other one, except we don't have any primes here. And basically, this segment DC is what's called a side splitter. That is going to be a side splitter if and only if DC is parallel to AB. All right, and what basically happens, I'm skipping over a lot of these words here so I can really get to the root of what's going on, is that this segment right here splits it up proportionally. So if AB is parallel to A prime, B prime, then OB to OB prime is going to equal OA to OA prime. In other words, the proportion that you can create says that the top part of one side, when compared to the whole thing, equals the same proportion as the top part of the other side when compared to its whole thing. And it's very easy to use. So if we come down here and use the side splitter theorem to solve for these values of x down here, I'm just going to set everything up. So if I set it up for number 1, I have 4.5 top to the whole thing, which is 4.5 plus x, not 4.5x, 4.5 plus x. I add the top and the bottom. So top to whole equals top to whole. 3 plus 4.5 is 7.5 over here. Now, when you have a proportion, when you have 2 fractions separated by an equals, to solve it, you can cross multiply. So 4.5 times 7.5, which I'm doing off screen here on my calculator, is 33.75. And then 3 times this is going to distribute. 3 times 4.5 is 13.5 plus 3x. I'm going to subtract 13.5. And I'm going to get 3x equals 20.25. I'm going to divide by 3. And I am going to get 6.75 equals x. And that's how you use a side splitter. Top to whole for one side equals top to whole for the other side. So if I do that same thing for this next triangle, this is the top part. The whole thing is 6. On this segment, 1.5 is the top part. The whole thing is what they're calling x. Cross multiply, 2x equals 6 times 1.5, which is 9. Divide by 2, x equals 4.5. All right, I want you to use that same idea, and I want you to try 3 and 4 on your own. So hit pause, try 3 and 4 on your own, and I will magically make the answers appear in a moment. Let's call 4. All right, so when you do your setup here, this one's a little bit different because you have 8 to 13 equals x to x plus 4, which gives you 2x's, which is fine, but when you cross multiply, you have 8x plus 32 and 13x over here. You solve, you get 6.4. And then if we finish that off for number 4, top to whole is 9 to x, top to whole is 6 to 16. I cross multiplied, I got 24. All right, now number 5 and number 6 end up being quadratic. So I'm going to do 6 with you, and then 5, we're going to try the whole pause thing again. So when we do 6, we're going to do top to whole equals top to whole. So when I come here, I'm going to have the top part, which is x plus 6, to the whole thing, which is when I add these two together, I'd get 2x plus 4. X plus x, 6 minus 2, 2x plus 4. And then on this other side, my top would be 15, and the whole thing would be 15 plus x minus 1, which is going to be x plus 14. Then, when I go to cross multiply on this thing, I end up having x plus 6 times x plus 14 and 15 times 2x plus 4. I apologize for these dot fragments here. And then we have to FOIL this out. So we have x squared plus 14x plus 6x plus 84. Distribute the 15 gives me 30x plus 60. So I have x squared plus 20x plus 84 equals 30x plus 60. Because I have an x squared, I need to set this equal to 0. So I have x squared minus 10x plus 24 equals 0, which is going to give me x minus 6, x minus 4. And so I am going to end up with x equals 6 and x equals 4. And it seems as though that both of those are solutions, because I could put a 6 in there and not have any negatives, and a 4 in and not have any negatives. So yeah, x can actually be two things here. So let's come up here and look at this one. You're going to set up the same thing and you're going to end up with a different quadratic. So I want you now to try number 5 and then unpause it and do it with me. So what you should have ended up with is x equals 4, and the reason being, when you try to do top to whole, my top is 2, the whole thing is 2 plus x plus 1, which is x plus 3, and this is x plus 6, which is 2x plus 6. So top to whole equals top to whole. Then when I cross multiplied, I distributed 4x plus 12, x squared plus 3x. I saw an x squared, so I set it equal to 0. I factored. I solved. And I said, wait a minute, x equals negative 3. If I plug that in here, I'd have a negative length. So we have to cross off that negative 3. Ta-da! Okay, now, in this problem set here, there's a couple that are kind of unique. So I'm actually going to do 2 of those with you right now. So if we look at, say, number 3, is VW a side splitter? Something is a side splitter if you knew that this is parallel to that, which I don't know, so I can't use that. It's also a side splitter if top to whole equals top to whole over here. So if I were to take these and figure out if these fractions are equivalent, you can do it right on the calculator and see if the fractions are equal. I have 2 to 3.5 and 6 to 10.5. So 2 divided by 3.5 is that number. I'm going to math frac it to get a fraction here. That's 4/7. And then I'm going to look at 6 to 10.5 and math frac that as well and get 4/7. Since 4/7 equals 4/7, yes, It's a side splitter because the side lengths are proportional. Okay? I know that's messy handwriting. It says proportional. Just trust me on that. All right, and then the other thing I want to talk about is 4 and 5. I'm going to do the first ones with you, and then you're going to do the other ones in class. So number 4, it says, what would be the best or most specific name for a shape that has the following ratios for sides? So I'm going to pick B. If I have a 4-sided shape whose sides are in a ratio of 4 to 5 and 4 to 5, that means I have a shape where the opposite sides are both 4x and the other opposite sides are both 5x. So the opposite sides are equal here, the opposite sides are equal there, which means that this would have to be a parallelogram. And then you're going to do the same type of thing for these, okay? What would be the best or most specific name for a shape that has the following ratios for angles? All right, I'm going to again do B here. If I have a 4-sided figure, I don't know that we've said this in a while, but a 4-sided figure has a grand total of 360 degrees with its angles. A triangle has 180 degrees, 4-sided has 360. Think about a square, 4 90s would add up to 360. So 4x plus 5x plus 4x plus 5x equals 360 if these are ratios for angles. So that's 18x equals 360. So x is 20 degrees. So my angles are 80 to 100 to 80 to 100. I'm noticing that the opposite angles are going to be equal and consecutive angles add up to 180. This is again a parallelogram. We're going to know they're parallelogram. Okay? All right, the rest of those you should be fine with. I will end with another ridiculous joke here today. The ridiculous joke is going to be, how do you make a witch itch? You take away the W. Why can't you hear a pterodactyl when it's in your bathroom? Because their P is silent.